Hey, this is stream number 19. So I am working on the design for my keyboard. I did some of this work off stream. So a couple things that I did, 3 things actually. I picked and placed the underglow LEDs. So if I show you the back layers only and flip the board upside down. So this larger footprint here is for a 50/50 NeoPixel LED. So a bit larger than this smaller through reverse mount part, but I'll show you on the 3D viewer what it looks like. So I'm placing 4 of them around the board. So if I go here and then flip the board upside down. So these are the per key LEDs, right? And these are the underglow LEDs. They're a bit bigger, which is fine. I was able to squeeze them in there. I'd rather have a bigger part than to mess with an even smaller surface mount part. It being surface mount already, it makes it challenging for me as is. I'm going to have to come in here and solder these edges to the pad. How do I show this? Is it shift? Forgot how I drag this thing. Huh. Anyway, I guess I can hit these arrows. Yeah, that'll work. Whoa, don't rotate too fast. So yeah, there are tiny little pins in there because it like starts up here and wraps underneath the board. So I just need to heat it and probably just put some solder in this joint right here. So added those underglow LEDs. There's 4 of them, like I said. 1, 2, 3, 4 on each side. The other thing I did was I renumbered or replaced the per key LEDs so that they're easier to route. So if I turn off the copper layer for a second, so here's NP1, and then 2, and then 3, and then it goes over, and then up, up, and then over, down, down, over, up, up, over, down, down, and then to the left, left, left. So not covering the keys in the original order. I haven't done that to the right-hand side yet. They're still ordered, I think, top to bottom, left to right. We're looking at it upside down, so it's right to left. But yeah, 22, 23, 24, 25. So I need to reorder this. These first 3 are correct, but then I got to move 25 to here. 26 stays, 27 goes up here. So let's turn off the nets for a second. Oh, the other thing I did was I'm making the traces fatter for the power and ground. So here's like a signal trace, and then here's a ground trace, so slightly wider. And I did that by putting the ground and power into a different net class called power. Hey there, Baker Staunch. I don't know why this takes a while to load, but yeah, so I made the power net class 0.35 track width instead of 0.25 millimeter. So slightly fatter. And the way I did the routing, it was hard to find tips and tricks on how to do routing successfully, but someone in chat said this, and then I found one or two sites that kind of confirmed it, that it's easier if you, on one layer, go like horizontal, and then the other layer go vertical. So on the back layer, I'm going mostly horizontal, and on the front layer, I'm going mostly vertical. So that allowed me to route this thing without too much skirting around things. There are a lot of vias, though. Wherever we have intersections between horizontal and vertical, we need to have vias. But I think that's fine. So we need to do the same thing on the right-hand side board. Let's flip and, well, not, hold on, let me not flip it, because I still need to remove the NeoPixels around. So the third thing I did is I placed these logos. So I didn't know how to place these before, and looked up how to do it. It wasn't that hard. I just needed to discover this image converter, right? Actually, I already have an image converter open. So you load your logo in here, And then here's the original picture, the grayscale, black and white. So what I did was I went negative and then put the threshold up to, I think it was just 100. And then exported to the file. Oh, I think I also played around with the size, just to make it the size that I liked. Exported it to a KiCad mod file, put it in my library, and then it ends up showing up when you do this place footprint. So under my project, I have Ferris and I have the Rust icon. So I decided to put them over here. So that wasn't too hard. Yeah, so the other thing, in order to get that underglow LED to show up, I had to go find a 3D model, and I had to make a footprint for that underglow LED. I suppose I could have searched around to find the footprint, but it wasn't too hard to draw here. Just place the pads where there should be. This line, I think, is the user drawing for showing where the actual like the actual dimensions of the NeoPixel, and then I added a courtyard around it because I don't want to place anything on top of like the pads or too close to it because it's a little bit tall. It's like 1.5 millimeters tall. And then to distinguish which pin is ground, I made a little thing on the silk screen, and the 3D model looks like that. So like I was saying before, if I show the footprint and 3D models, I guess I'll just have to lift it off here to show you what it is. So lift it quite a bit off, right? So it's, the pads on this are kind of funny. Rather than sticking out like normal on surface mount, they kind of curl under. So I decided to make them like where it curls under, to make it the pad there, but when it rests down on the board like that, basically I don't intend to have any solder directly under. I'm just going to kind of solder onto the side, and I think that should be good enough. Just stick it to the side, right? That's what I am planning to do with this thing. Alright, so the tasks I have for today, like I was starting to do, I need to put the NeoPixels on the right hand side in the same kind of snaky path. The reason why we start here is it's this trace right there is where from our microcontroller where the signal goes to, and then after that is daisy chained. So we're making the path like straight down, daisy chain down, and then rather than going from here all the way back up to here, I decided, well, we'll just go to the right. So that's where you'll see this one go to the right, and then this one goes up, and then from here it goes right, and then down, and then down, and then right, and then up. So basically keeping the daisy chain such that from one to the next, you don't have to go very far, right? And then we'll do the thumbs last. All right, so need to do the same thing over here. Before I do the traces, I want to place them in the correct places. So let's do backlayers only. Let's turn off the nets for now. Turn off the, what is it, the fab drawing, the fab markers. I want to turn on, is it user drawing or margin? Courtyard. Yeah, courtyard, to see relatively the shape of where the key is, right? Because that's roughly where I want to put the NeoPixel with its edge cut, so that it's shining up through the switch at around you know, roughly the right area. Okay, so 22 is closest to the signal it needs to go to. It's not showing up. Net 31. Wait a minute. Hold on. Do I have the right NeoPixel? Does it start at 22? It doesn't start at 22, does it? It starts at 19. Yeah. Yeah. So here's where the signal originates from. So I think it makes sense to start here and go either to here or to here and the snake around. So kind of mirroring what I had on the right hand side where I started in the corner. We kind of want to put it up there, right? So let's move this one out of the way. Put 19 there. Gonna need to undo the rotation in that. Oh, I need to make the grid align to 1 millimeter, right? Actually, I need to go right between that. So let's put grid to 0.5 millimeter. Yeah, like right there. And then 20 goes here, so that one needs to move. Here's 20. 21 is next. Right here. Unrotate that one. And then we'll go to the left to go to 22. Let's find 22. Right here. And then 23 is up from there. And then 24 goes there. And then 25 is up there. Okay, and then 26, where are you? 26. 26. And then 27. Then 28 over here. 29. I'm just so much looking forward to doing all the soldering work with this. Not. And then to the left for 31. Then 32. 33. And then we'll go right over to the thumb, the inner thumb for 34. So rotate 20 degrees. And that's close enough. It's close enough. And then 35. Where'd you go, 35? Oh, my mic was off the whole time? Jeez. Sorry about that. At what point did the mic cut out? Maybe I hit a hotkey that turned off the mic. I hope it wasn't off for the last 15 minutes. How embarrassing. I'll have to look back at my recording and find out how long it's been off. Hey there, Red Rampage Carpet. I hope, I hope I wasn't muted for the last 15 minutes. Thank you for pointing that out, Baker Staunch. Just the last minute or two. It's bad, but it could be worse, right? I'm mostly just kind of chattering while I'm working on fixing. What I'm doing is fixing it so that the silkscreen markers aren't intersecting any holes, pads, or cutouts. So, and they should make sense, right? They should be like not ambiguous. Like it would be bad if this one was over here because you're like, okay, which one is it, right? And P stands for NeoPixel, by the way. This is the little LED packages that we're placing. 34, 35. I kind of like placing it under. Let's do that. Oops. Yeah, I wonder what key I accidentally hit that turned off the mic. Okay, how does this look? Oh, there's a diode K marker that's wrong. How about, I'll just put it there. One thing I did on the left-hand side board that I might want to do on the right is it kind of looked nice, and I don't need them after placing, but to put the silk screen for the marker inside the depiction of the diode, right? So in other words, like this. I think I'm going to do that. For consistency, it also kind of saves space if I want to put other markers. And like I said, I don't really need these silkscreen markers after I put the diode in place. If I really want to know what diode is, I'd probably just refer back to the PCB file. Okay, and diode 27, diode 20. This one, can I rotate that one? No, this has the rotation bug on it. I just want to do that. What did I do on the other side? Oh, for that one, I kept it outside. Okay, so maybe I'll just do the same thing over here. Just leave it out. Leave that one outside. Hey there, Pomp Rocks. Why no SMD components? I do have SMD components. I just don't have SMD diodes. Let me show you the SMD components I do have. All of my LEDs are surface mount. They're more challenging to solder, but I really don't have a whole lot of options here. So yeah, I'm like, diodes, I don't need the tiny ones. Adam had trouble with them. I'm like, no, that's okay. We can do through hole ones. These switches actually are surface mount, but they're rather big, so they don't really count. But yeah, these NeoPixels are surface mount, and they were a pain for me to solder. But I don't really have much choice because these are the neat ones that shine through the board. It's kind of hard for me to do this. Can I? Oh, it's right-click drag. Perfect. So it kind of shine through the board so that you see the light from through the board, but they are surface mount. And I also have these new surface mount things I added for the underglow LEDs, so they're shining straight up or down if you flip this around. Basic stuff like diodes, resistors are pretty cheap to have them put on for you. I kind of felt like part of the process of building it myself was doing the assembly. If I had the machinery to print the circuit board, I'd do that too, but I don't. Maybe next time. Actually, probably after I do all this, I'll be like, I'm never doing that again. I'm going to do what Pomp Rock said and have someone assemble it for me. Then if I had someone else assemble it, I would, just to get rid of these holes, I would use a surface mount diode. But everything else would actually stay the same. Right? Because everything else is either surface mount or it is like connectors and stuff. I don't know. I find doing the through-hole diodes fun. The SMD parts not so much. They're more of a challenge. So, you know, it is what it is. I've personalized the board. People look at it and say, like, why didn't you use surface mount diodes? And I'll be like, I don't know, didn't want to. So this is my board. I can do what I want. Okay, fix these markers, and I'll move on to the more fun stuff, which is the layout. I mean, the routing. So I'm looking for obvious errors. How about the underglows? They're pretty well marked. Okay, I think we're looking good. We're looking good. Save that. Let's do routing. So let's do view, flip board, all layers, but turn off the fab markers. Okay. So off screen, off stream, I should say, I did the routing for the left-hand side, and just because it was late last night, I didn't feel like streaming, but I felt like doing some of my hobby work. And like I said before, I had a lot of success routing horizontal for one layer and vertical for the other. And I believe the order in which I did things was I did the rows and columns first, then I did the neopixels, and then I did the power and ground. And then I kind of regretted doing the power and ground last. And I thought to myself, maybe I should do the power ground first, then the rows, columns, then the neopixel chain. So I think maybe that's what I'll try to do tonight. So let's do power ground, right? So one convenient thing is I can turn off all nets but power, and now we have the rat's nest for just the power. And you kind of see how in general I'm going to want to start here and make like a horizontal chain and then go vertical around here. There's a lot of connections over here. And they just turn off left-hand side, and then turn off, let's just look at ground, for example. So I'm going to want to go over here and then kind of go down and across, and then here we'll want to go across that way, maybe across this way too, and we're going to go vertical again to reach all of those LEDs. So same thing with power. I think power is actually a little bit simpler because we don't have these ground holes we need to go to. So it's just across basically three or four rows across, and then maybe a few down. It's like a simple lattice. Let's start with power. Do which side? I think I was trying to do ground with backside and power. Actually, it looks like I abandoned that. I was going to say ground with one side and power with the other side, but it doesn't really matter. I think we're going to stick with backside for horizontal. So if we're going mostly horizontal from here, I would go backside and let's do that. And then we can just go down from here all the way down. But we also have a power connection we need to connect over here. Power and ground. Oh, these ones are special. When I worked on the soldering for this board, it was mostly on the back side and making solder bridges here and then cleaning up the solder bridges. I actually scraped off some of the solder mask and exposed the traces on the back side. So I was trying to avoid backside traces where I could. Why didn't I use backside trace there, though? I think I was worried that I had power and ground too close together, but it doesn't really matter, right? Can I just put this all on the back side? Whoop, wrong key. Delete, right? I think I can just make this all backside traces. I don't want to delete all of it. Let me do backside traces for these connections. Yeah. Or front side. I wanted to avoid backside traces around power and ground where I had trouble before. So let's do the same thing over here. So front side traces, power and ground. Maybe one reason I had power on the backside is I was worried about a short. I was worried about a short between the shell and the power trace. That's what it was. Yeah. Let's put those back. Yeah. I think I was more worried about a short from the shell of the connector to power than I was about any kind of like possible issue with the solder mask later. So I wanted to use backside trace for power, front side trace for ground, and had like plenty of interground connections, right? Did I even have one across? Yeah, I even had one down because, you know, why not? Okay, so then we want to power on backside, basically going straight across here and down, easy peasy, right? And then, yeah, we're gonna like have a bridge up down here. So let's start from here and go out to a via. Okay, my grid is too shallow. That's the problem. Let me do grid 0.1. There we go. Nice increase in resolution. Okay, so we're going down. We have to avoid that hole. It's probably better to go down the other way, right? Go down here. And we'll go to a via over there. And then same thing up here, right? Can I go through there? No, I can't. So we'll go around this other way to a via around here. Oh wait, is that not? Oh, wrong. That's the wrong pad. I did the wrong one. That is actually a daisy chain connection. That's fine. I meant to do this one though. From here, I want to go to a via and go around this way and hit a via there. Yeah, that's what I want. And then I guess we can move that via out to match up there. All right, and then up and hit a via there. Perfect. So that connects power through these LEDs over to the chip and to the connector. I think on the other side, I also had a direct connection from power from the connector to the chip. So let's do the same thing there. That was from here all the way up. And then actually it'd be better just to go over to a via here and then go up. And then just go up all the way and plug in there. Like that. All right. Cool. And so got to go across from here, right? So up and across. What's the best way to do this? This one's going to be tough. I really want to go and hit that direction. Can I just go from here maybe? And go down and over? Yeah, that makes more sense. This one's easy. Okay. I'm going to have a little bit of a problem. Like I've isolated row 0, so what I'll probably end up doing actually is giving this a bit more space by moving this trace over. I don't know how I want to do this. I'm not exactly sure how I want to do this. I'm just making it uglier. Let's delete it. There we go. And then yeah, something like this, and they'll have a via here to go to row 0. I might as well do that now, right? So here to a via, go up, and then via right, like that. Okay. this I should just move, right? Over to there. All right. We went over to here. We kind of think it would be hard to squeeze through there. Yeah, we can't squeeze through there, so we might as well not try to have power go under between these holes here. I think I'll do what this suggests and try to go from here over to here next. So squeeze under here. I wonder if it's dangerous to put a power trace under here. Well, no, the LED doesn't have a grounded shell, so it should be fine, right? Yeah, I think I don't need to worry about that. I'm thinking like I don't want to cause a short between this power line and the part which might be grounded above it, but I don't think I need to worry about that. Okay. So this is suggesting that I go down, which I think I will do. Can I go? How about if I go? What I really want to do is via up from here, like that, and then via back. There we go. Okay, and then this one should be easy, right? A power over and around and up to that pad. So like that. Whoa. Let's clean that up. There we go. Next, I'm going to get power up here vertically. I think best would be to just take this via and extend out for, yeah, exactly, and just go up here and do another via over. Easy. Okay, and then down to here. What's the best way to do that? Maybe go through here. So start here and go over and then via. There we go. And then here's another trick. I can do from here to a via around here or so, and then just go straight down via back. Okay. How are we doing? So you can see that the network extending from the left, kind of extending over to the right. I'd like there to be more than one path through for power, like not have everything go through one trace here. So like I might want to maybe go over here to have a topside connection. Let's try that. So what I'll do is I will go from the right and go left. I'll go over here. Just go around the diode, and then I'll go right until I'm vertically above that. Hit it. That's weird. Hitting V didn't show it right away. And then go down, and then via back. So now I have two avenues for power, the top and the bottom avenue, right? And then, well, there's a top, middle, and bottom. All right, so I can go from here to here, maybe. See, I'm gonna have trouble going through these. Well, I guess I do have some space. I risk, like, cutting off access to the other pads around here. Hey there, Lee Spike. Hope you're enjoying me doing some board design and routing here. Okay. I'm routing the power to my LEDs right now. Can I do the same trick? Ooh, I can. Let's do the same trick. And then over to its neighbor. Okay, and this is suggesting, which I think is a good idea, to go up here. But I'm going to do this trick where I go over here to a via. I'm trying to make it so vertical is preferably, like, prefer to do the vertical paths with the front side copper, the red. Backside copper blue, trying to keep that as horizontal as I can. Oh, I'm glad you enjoyed the stream. This is mostly horizontal, so we'll just do this and go up. And then I think I'm okay with it. You just need to go 2 down from here. So we'll just go across via and then up via. And then I'll clean up this via position. It's not quite right there. And then we'll just go down from there to meet this other power pad here. So do you guys know any other streams of people actually doing circuit board design? Because I don't know of any. I might not even be in the correct category. Most of my streams to build the keyboard is going to be software, so I put it into software and game dev. But really, I guess it should have been in science and tech, and then, I don't know, within science and tech, does anyone else do the same kind of thing? I haven't ever seen this before, otherwise I'd be watching it to pick up some tips, but as far as I know, I don't know of anyone who streams this kind of stuff. Okay, this one was trouble for me last night going the other way. I think I just gave up and went around, so do the same thing. We'll just go kind of out. I want to give that... Oh, that's a not connected pad. We don't need to care about that. So we can go completely around that guy. We're not connecting him to anything. Yeah, we'll just do that. Easy. Unless I need a signal to go across here, in which case I'll do a via. But I can wait until later to do that. Alright, so do we have any unconnected power? I don't see any. Let's hide everything. There should be an easy way to like hide everything. Okay, just look for unconnected nets. There aren't any. Cool. So back to all layers, turn off fab lines. And then, yes, so we've connected all the power. So then we can hide the power and show the ground too. And connect these guys. So let's see. We need ground to go from here to here. Easy enough, right? So backside copper, go like down around here and up. All right, then we want ground to go down here. Here I might, I'm kind of cutting off on a horizontal avenue here. I might want to do a via. In fact, I'm going to do that right now. I'm going to assume that we need this avenue open for other things. So what we do is we go to a via here and we just connect ground on the front side. Right? Okay, and then here, I'm a little uncomfortable with this trace getting so close to ground, so we'll just kind of drag it like that. And I really don't like that either, so let's drag these out of the way a little bit. Come on, drag. There you go. And drag. You kind of want to keep to these 45-degree angles. You don't want like a 90-degree angle if you can avoid it. All right, and then just do my what I've been doing here, which is we go up to a convenient place so that we can via all the way up to ground like that. In fact, I'm going to clean this up so that it's actually lined up like that. Okay. And then we're just trying to get ground, like migrate ground from left to right. Okay, here's one that's easy. Easy. And then, okay, this one we'll do with backside copper. Done. Okay, here's where I already regret doing this backside trace. We've cut off our access to this ground if we were to go through here. I could go down around here, but that's probably okay. Really what I probably should have done is make another via for power and go straight down. But that's okay. We'll just go around the other way here. So like around here and then up. Oop, that didn't quite work. So you kind of have to do intermediate clicks sometimes on this thing. And I don't know why, other than maybe I'm reaching like the limit of its logic. How far I can look ahead and see if the trace looks like the proper path. I do that. I am cutting off this, well, there's not much room here anyway, so that's fine. What you want to do is kind of, if you're violating your own rule, like if blue is supposed to be horizontal and I do a vertical thing here, that's okay as long as you're not going to want to go anything through there, which nothing is going to fit here. if I was to go through here, I'd probably do it vertically with the red front side trace anyway. So this is probably okay, right? And so nothing else is going to go through here. It's probably safe to just do that. Although, let me follow my own rule and do it on the front side. Oh, that's on the backside. It has to be backside, right? Unless I do a via. What switches will you use in the board? I'm using Cherry MX switches. And they're hot swappable. And I don't know if most switches are interchangeable, but Cherry MXs are. Especially if they're hot swap, you can, you don't have to do any desoldering. You can just pop them off and then plug them back in. Like, let me demonstrate. I didn't mean to hit a key. It's actually a functional keyboard, this prototype keyboard. But watch this, I can pop the key right out. So it's got two little pins on the bottom side, and it plugs into the switch. And this is the Cherry MX style switch. I don't want to do that really quickly, I might damage it. You want to make sure the pins are actually going in. There we go. Okay, and then I was actually accidentally hitting a key when I was doing that. So, Cherry MX switch, right? They have a distinctive look. They have the two pins on the bottom, and then that white peg, and then this channel for light for the LEDs that you usually want to light them up with. And they have that plus symbol. It's actually easier to see with this brown. Right, there's that plus. That's where I can't get it. I'm still not used to my own camera. That plus is the shape of what the keycaps plug into, right? So all Cherry MXs are interchangeable, but if you were to get a chalk switch, a low profile, they have a different shape. The dead giveaway is that you'll see that some switches have, well, switches that are incompatible with each other will have like different shapes for that little plug that the keycap goes onto, right? That's a dead giveaway that they're not compatible. The other way they might not be compatible is some of them, like the geometry of where those two pins are. So for the Cherry MX switch, you can see one pin is like slightly offset vertically, so it matches this. Like here's one hole and here's the other hole. They're offset vertically slightly. Chalk switches, the low profile ones, I think are arranged more like one here and then one up here or something like that. Or maybe it's one here and one over here. So they'll actually have a different geometry, and the last thing you want is to pick an incompatible switch and socket and find that you can't plug the thing in. So I think the Cherry MX switches are used in a lot of places, so that's what I'm starting with. They seem to be like the easiest to prototype with. They're pretty popular, and then I've heard of the chalk switches are for low profile. Those are also popular, but then there are like tons and tons of other kinds of switches, and I don't know much about them. But just again, they follow the rule of look for the geometry of the pins, and look for the shape of the plug for your keycap, and that kind of tells you what's compatible with what. Also, I'm working with hot swappable switches, right? There are the non-hot swappable switches that are meant to be soldered in that are probably completely different. Yeah, and a buff seagull knows a lot about switches, so most everything is MX compatible. There you go. You've heard it from the buff seagull source. Okay, let's connect this one. Should be easy, right? I don't like that it brings the trace so close to the diode there. I kind of prefer it to be that. Although this is cutting off an avenue for that pad. Where does that need to go? Yeah, so I don't want to do that because it's cutting off the avenue for that pad. So let's undo that. I think what I'll do is I will go from here over to a via, because we're gonna want to go down to this pad anyway. We'll go to a via. Doesn't really matter where, but let's go out to here, right? And then from here we'll go over to there, and then we'll also branch out and go down here to this guy. Via here. So I don't like that it does this. Well, actually, those are on different layers, so it doesn't matter. We want to avoid these holes, though, right? So let's move that so we kind of avoid that hole. as much as we can. And then this one, that's probably fine. But maybe to be safe, we'll do this kind of a thing. Again, we're trying to avoid these 90-degree angles, but this one's probably okay. Actually, if we want to really avoid it, we would do this. And then there's like a Y, right? Yeah, let's do that. Your roommate did buy a 96 switch tester? Why do you need a 96? What is 90? Does that mean there are 96 switches on the same board? Or is it 96 mean something else? If it's 96 switches on a board, that seems like a lot of switches for just testing. Okay, so ground, I don't want to cut off this avenue completely. I'm wondering if I should go from here horizontally over. That's probably best, right? So we'll go here and go horizontally, and we'll just via back to here. Oh, that's the wrong trace? What? How come it doesn't want me to... How come it didn't want me to do that? Okay, now it will let me do it. That was weird. Okay. All right, and here's a good place to go to a via and then just go up through here and then via back. Via back to here. Okay, we want to avoid that angle though. Let me redo that. Go to a via here. Okay, I like that angle of approach, that angle. So I'm clicking to kind of confirm that, yeah, that's the angle we want. Again, this is on the other side, so it doesn't matter. All right, and then I don't want to cut off access to this pad, so what I'll do is I'll go to another via. Like that. So we're giving a horizontal path for that pad, because we're going to connect that later. All right, this one's easy. Although I think it's better to do this and then via to the ground, right? So we don't cut off access to that pad. All right, let's line this ground one up. All right. Let's do this one because it's at the bottom. How do I want to do this? Probably, since we're at the bottom, there's not going to be probably anything else that needs to go close to this pin. We can kind of break our rule here. And so I can just go to like a via immediately and then yeah, via immediately and just cut across like that. And then to get rid of these 90-degree angles, we can do this little trick where we just whoop. We drag, if it'll let me, drag. I need to get rid of this point here. There we go. Can I just like drag this? It's not letting me do it. Okay, it's being... Okay, let me force a bend here to begin with. Yeah, and then let's try this again. I don't want that acute, this small angle. Yeah, we want to do something like that, right? So there's no, okay, there's still a 90-degree angle, but we can fix that. How come this is being so testy today? Yeah, a Y like that. Well, there's still a 90-degree angle in that. There's only one 90-degree angle. Yeah, let's bring this back over here. I think that's probably good enough. 96 different key switches just sitting on a grid. So like one of each of the different cherry switches. Oh, wow. So like something where you'd have like every imaginable kind of switch, you can kind of compare the feel. That's pretty cool. Seems excessive though. I'm contemplating redoing this because I didn't like breaking my own rule here. I think I'm going to do that. I'm going to redo this part. So let's pick this whole trace and delete it, and I'm going to take this whole one and delete it as well. Let's continue down and then just via over to, let's try that again, via down here or around. And drag this away a little bit again. Like that. Just to give that pad a little space, you know? Okay, and then I can horizontal over here via, and then I probably don't need to do this, but just trying to follow my own rules and I'll keep a channel through here. We can bring backside copper through there, right? And this one I can pick this to go straight down to this via here. All right. Okay. Here's an easy one. How are we doing? Okay, we need to have some kind of vertical path through here for ground. I like this suggestion. So here, via, and then a front side up to a via there. Perfect. And then we're going to go down and end up here. So this already has a front side trace here. So what if we just connect these with a front side trace? We'll just go through, we'll go around this way. And we'll connect like that. Yeah. I wonder why I didn't want to draw directly there. There, I fixed it. Okay, cool. So now we got ground going up that way. So we got kind of two horizontal paths through the board, and then they kind of meet in exchange with this vertical path, and then they continue going horizontal. So we want to do another horizontal path through here. Yeah, that's a hole. We want to avoid that, right? So I don't want to cut off. Where does this go? It goes up. Okay, so then I can cut it off horizontally then. I can just do that. Because there's not going to be anything else that... This is just going to go to a via and then go straight up anyway, right? So it doesn't matter. Okay, what else? Okay, from here to here, let's do that one. That's easy, right? We just go like that. Where does that one go? Oh, wait. Let's just do this one. That's super easy. Zip. I don't know why I did that crazy zigzag, but let's fix that. Neat. Looks like New York City subway system. I mean, I kind of thought of it as like almost a freeway system where you have bridges instead of vias, right? Or I guess on-ramps and off-ramps where they are connected. No, so yeah, the vias are like freeway connections, and then you have north-southbound freeways and west-east bound freeways, and then they have bridges crossing each other occasionally. But sure, subway system analogy works too. All right, for this, I think I don't want to cut off this pad, which needs to go to the left, right? So let's have this go here and then via up to that. I keep hitting the wrong key. V, click, drag up, click, right? If you're wondering what these big grounds are, I put them, 4 of them on the board. They kind of have 2 purposes. They're for like ground, like connecting ground to a chassis if I had a metal chassis, but they're just in general screw holes so that we can screw it into a case. So they kind of have a dual purpose. They're convenient ground points, and they're also screw holes through the board. All right, how are we doing? Okay, we need a connection over to this ground, so let's go mostly horizontal, and then I guess we'll have a short jaunt there because we want to like maintain a lane open here. Okay, and then we're gonna want to go vertical here. So might as well go out to the edge here to skirt those holes. Via, and then just go up, and then via, and then back. All right, and then we want to go up from here. So let's, perfect. We'll just go over, via, and then down. Connect directly. How come it's not letting me do it? Come on, you can do it. Is it trying to skirt that hole there? I think it is. So we'll just do that, and then I'll move, what I'll do is I'll move this guy over. Yeah, like that. Okay, because we're skirting the whole of this diode, right? All right, where else do we need a ground connection? Okay, horizontally from here. That's easy. And then horizontally over here, that's also... Oh, where does this one need to go? That one needs to go down, so I can cut him off horizontally. He'll just go over here via and down, right? Okay. Here, I don't want to cut off that lane, so I'll just do via to ground. How are we doing? I mean, that looks good, right? I connected all the grounds. Oh no, there's one unconnected ground. Yeah, so this is an island, it needs a connection. Yeah, so let's go over to here and via up. And then via back. Cool. Alright, so there's our ground. Oh, see how there's a connection through here, but there's no connection over here? I kind of want to have two paths, so what if I connect here to here? Like this. Just to kind of have a natural path up there. Just so that there's like two ways that ground connects. It connects on the bottom and it connects near the top middle-ish. That makes me feel better. Okay, let's save this. Okay. We've connected power and ground. Next is rows and columns. So quick refresher on what that is. Here's on the schematic page what these switches are. So we have a bunch of row signals and we have a bunch of column signals. In general, the way it works is about 10,000 times per second. We go through the rows and they're driven high, all driven high to begin with. And we each in one at a time drive one of them low. And then while driving one of them low, we read the column inputs. So that rows are outputs and the columns are inputs. I don't really have the right symbol here, but you get the idea. Drive us a low signal in and we see which column goes low. It goes low only if the switch is pressed down because we have diodes to make sure that the current can only go in one direction, can only go from columns and sync back into the row, right? So if you aren't pressing the button, the key, then this column doesn't get driven low. The only way it can be driven low, if row 0 is the only thing being driven low, the only way it can get that low signal can get to column 0 is if this switch is pressed down. And then, so each column like is tied to the switch next to it for the row you're driving low. So row 0 lets us sense switches 19, 22, 25, 28, etc. based on which rows go low. And then we drive it back high, and then we go drive row 1 low, and we read the columns again. That tells us the state of switches 20, 23, 26, etc. You get the picture. So I need to connect rows are outputs from the controller board, and columns are inputs. And they are all here, right? Here are the 3 row outputs, and then the columns inputs are on the left. So in general, I have them arranged geometrically, so like row 1 is all horizontal in the middle. This one's row 0. It's the top side. And then row 2 is the bottom plus the thumbs. Oh, that's right. There's one oddity in that the thumbs, like, row 0 is the top plus the left thumb. Row 1 is the middle row plus the middle thumb. And then row 2 is the bottom row plus the right thumb. So we'll have little branches that go down to the thumbs, but in general, the rows are going to go from left to right. So if I kept my lanes open here, we should have paths. Okay, looks like I cut myself off here. I should probably fix that, right? To fix this the right way, I think what I should do is go to... really just delete this trace and go up here and go across, right? Let's do that. So delete this particular trace. Delete that one. Do we even need, we didn't even need that one. That was an extra one, right? That was this one, right? Yeah, because we have an alternate power connection. But if we really wanted to go have a topside connection, then we can just extend this up to here and via over, right? I'm just going to do that. Why not, right? So now we have a clear path from this switch to the next switch in the same row. Oh, except for that thing. Let's go around the diode then. And down. Okay, and then we're continuing on to the right. So this has got to pass through here. So let's go via to via and then over. Okay, and then we're going to the next switch over. Here we... Can I go down? No, there's no room there. So we'll go up and over. Like this. And then we need to go one more switch over and it's kind of down and to the right. So we have a pathway through here. Got to go around the hole though. Let's do that by doing a via down. I don't like the way it's drawing this trace. Really should just do that. And then that. Via down. Via over. Okay, and then we have one more to do, right? I need to go get down to that bottom thumb. So I think what I'll do is I'll go from here down. Yeah, so that means going to a via out here and then just going straight up. And let's clean that up by making that line up, and then I'll move this via to be right in the middle there. Fix this trace to be over. Fix this via to be right there. Unless maybe I'm thinking that via is too close, and then I can drag that away and then it kind of does a little jaunt there. Okay, so that's row 0. It's all connected. Let's do row 1 next. Row 1 needs to go to its pin down here. Okay. Row 1 and 2 are going to run into each other if I just do a straight trace down there. Unless this one goes around this way. I think I can do that. Let's do that for now. This is kind of violating my left to right only rule by going down. So we're cutting off row 2, but row 2 can be clever and do a little jaunt around, right? Because I don't need any, there are no more signals to connect. Actually, that's not true. All the column ones need to go through. So I don't want to do that. Okay, let's do this the right way. So the right way would be, let's just go over via, down via, across. Okay. So let's go over, and then to get to the thumb, let's go down from here, right? So over. And then like that. Where does that go? Oh, that's isolated. So I'm not cutting that pad off. Where does that go? That's the column ones. Okay, so we're fine. So then row 1, let's go down from here. Actually, here's a good opportunity to go down. We'll go down from a via here and meet it at here, right? So we'll go here to a via, let's pick a nice place like here. Go straight up and via back. Okay, and then continuing row 1, it's got to go right and then up. So let's go, let's do the right path first, and then we'll just go up from here. So via here, and then via to there. I think I got one more for row 1. Which one did I just do? That one? Yes. So I got 2 more I gotta go from there. I gotta go 2 right more. Okay. So kind of going down here and then go straight across, right? All right, and then here, we need to go down a little ways. So let's go up around here. Down, and we'll do a via around here-ish. Down, and then via back to the pad. Cool. So column 1 is connected. And we just row 1 is connected. So row 2 is the last one, right? So row 2 has got to go around the bottom, and then somewhere in the middle we'll just go down to the thumb. So going down, so via here to there, and then we'll go across. Oh, there's something we have to go around there. Go around this way. And then down. Cutting off that column though, if I do that. That's okay because he just needs to go up. So I'll give him room to make a via and go up. And then that's fine, right? So this needs to go up to here or down to there. Up might be better. Let's go across first. And then from here we'll do via up, via across, and then go across left, via up. And then let me clean up this, got a little bit of travel there. Actually, I think that's a little close to that hole, so what if we move this up a bit and move that via up a bit. This is off a little bit, so let's fix that. And fix that. I don't know, I'm a perfectionist. It's what I have to deal with. That's okay. I'm also a compulsive saver because I've had data loss in the past where I don't hit save and then I lose a bunch of stuff. So you'll see me hit save a lot. It's okay, right? Let's go down to here, and then can we just go straight down, or am I going to cut something off? I'll fix it later if I am cutting something off. This one I feel like it should go up, down here, to a via that goes straight down. And then up. That might be too close to the hole, though. How about we move that up to there? Move that like that. That makes me feel a little bit better about it. Okay. That's it, right? Row 2 connected. Okay, so all the rows are connected, all the powers and grounds are connected. We need to get the columns and then the LED daisy chain through this whole mess. Okay, so columns. Here's column 0. It's got to go down and across it's the thumb column, right? So let's just go across and then down. And then across. This will put the silk screen on top of that trace, so maybe what we want to do is bend that. Or I can move Ferris a little bit over. There we go. He won't mind. All right. Connecting the column from the left thumb to the middle thumb. Let's go from here and like follow along this road path, and then we'll just do a via straight down. Because that's a hole we can connect on either side. Right? That's the other advantage of having through hole parts, is I can connect either side copper to the hole and it works, because it doubles as a via. Okay, and backside copper under the diode, I guess. Yeah, let's go this way and then over. Perfect. And that's column 0. So next column. Column 1 right. Okay, so this is this column. So the thumb is a column, but it's sort of tilted over to the right. It's like a pile of 3 dominoes that kind of fell over, and these other 5 are columns that are still standing, right? So we need to go across. We have an avenue through here, and then I need to go a via down, right? So let's go over here, via down. Perfect. And so then we're going to go up from this point, right? So all these are going to go front side copper straight down, skirting this hole, right? And then there, easy. And up, skirt the hole and connect, easy. Perfect. So you can see the advantage to like always doing blue left to right if we can, and red up and down, is because even though we laid traces across there, we could easily bridge over them just by staying on the front top side. Okay, so then column 2 is the next one over. So we have a path through here. Right? We squeeze through here? No. We squeeze through here. We can squeeze through here though. Right under there. I should be able to squeeze. No, I can't squeeze through there. Okay. Abort. I need a route through this mess. So what am I gonna do? Really, I need to go under here. Yeah, there we go. And then up. There we go. Skirting kind of close to that pad, but going between that pad and that hole. I can move this via down. It doesn't need to be that high up. It could be like further down here. I give this more room. So then this trace can kind of... I'm not too concerned about traces being close together. I am concerned about traces being too close to pads and holes, though. Especially this edge cut. So I kind of want to leave it like that. Okay, and then from here it goes up and down, right? Or basically goes up. So then we'll go front side copper and we'll just go up. And skirt the hole on the left side. And go... How come it doesn't want to go... Oh, there's a red trace there. Ooh. I broke my rule and broke my own rule here. Let's fix that. That's what happens when you break the rule. You cause barriers. So let's delete that guy. And we'll go... let's go across on the top. So, like this. And there. Fixed it. I might want to go to a via here instead, though, because I'm potentially cutting off access there. Oh yeah, I am. Definitely am. I remember this now. This should... So this really the best thing is to go to a via here. So this can skirt through here when it needs to. All right. So then back to row... This one? I guess we can continue where this left off. Just go straight up. Okay. And we're going to need to go up from here. Same thing. We have like some gap here, and then yeah, best to go skirt. Okay, let's move that via because he's kind of getting in our way. Move it up a little bit, and then this can then clear it easily. Neat. Okay, column 2 connected. Column 3 is next. Save. Column 3. So column 3 needs to go all the way over to the right and a little bit up. So we need to go up. I'm just looking for a pathway through. We can go through here, but how do I get through here? This is a little tight. I think we're going to end up going up through here first. Go through here. And then up. Sure, let's up this. Yes, there we go. We found a path. Sort of. Actually, I might as well go to that one up there. I could always bend, like, if I really can't find a path, I can go along the top and then just go straight down, right? But I got most of the way there. Let's just go to a via. And go straight down from the via. Why is it not letting me draw that? I don't know. Where is the end of that? Right here. It's having trouble going up from there. There we go. Oh, I went too far. We don't need... Well, actually, where are we going from here? I'm going to that hole down there. Yeah, delete. Well, can I just move this one? It doesn't like me moving that. Let's just delete it. Okay, X from here, via, down, connect. And then just go up from here, skirt that, and go there. And then one more switch up. So out and up, and over. Easy. Okay. That was row 2. I have 2 more rows to do. Row 4 is the ring finger. So here it's going to become harder and harder to navigate through the middle of the board. And I'm gonna start seeing going over the top as being more attractive. Makes me think I should have routed rows 4 and 5 last. Or columns 4 and 5. Columns 4 and 5 last. Yeah, I think I'm going to give up and just go straight up from here. Let's go like via from here and then just go up. Oh, I'm hitting that. Shoot. I need some room here. Let's move this entire trace over. It's not letting me drag it. Okay, now it is. Let's move that over to there. And we can move this V out of the way right there. Okay, and then now I got lots of space, so I can go across via here, via out here, and then we're just going to use this top avenue, go straight across. All the way over these other switches. Why is it so confused? I don't know, but just have clicking multiple times, and then we can clean up the traces after we're placed. So let's fix this up a little bit. Let's have that bend a lot earlier. In fact, that's a much better shape anyway. Yeah. Well, let's give a little bit more room there. And then I can relax this a bit. Morning, Dr. Padawan. How are you today? Whoa, what's it doing there? See that? Why is it dragging the bottom of the line? Yeah, I don't want it to drag the bottom of the line. Yeah, I want to do something like that where we're like staying away from that top edge cut because we don't really need to hit it. In fact, this can... Yeah, we're going to skirt that diode around here. Okay. So then from here, we're going straight down, right? So this is the easy part. We just go skirt... skirt that hole like that, and then back in. And then again, skirt the hole on the left side, and then go back down in. And then, was that it? That was it. That was column 4. And then column 5 is over here, so it's going to go, same thing, it's just going to follow this other guy. Let's give him some more room. It's not letting me drag it. There we go. I like to give those vias and any other holes like a little bit wider margin if I can afford it. Okay, so then that last column is here. So let's just do the same thing just for consistency. Via up to a via. And then it's just going to follow the highway. This is our top board highway. Right? Because we can. Because why not? Goes all the way around this diode and then down to there. Clean this up a bit, like exactly dragging this it's giving me troubles, chat. There we go. That's what I wanted to do. Okay, front side copper, skirting the hole and then down. And then again, plenty of room. Down. And we're done. We're done with rows and columns. Yay! I only have the LED lights to route, so that should show up if I just show all, right? So this last remaining rat's nest, if I were to hide the copper layers, is the neopixels. Okay, there are 2 chains actually. There's the underglow. Let's show them by net. The underglow, right, and then the keys, right. So if we're just hiding the per key one, oh, that's going to show all these other nets. Yeah, okay, so it's going to be kind of hard to see. Here's the underglow one. It goes to this LED, and then from there, it's got to go up, and then over, and then down. So we're just going to follow the traces, right? So this has got to go over and then down. We need some kind of route to get down here, down to there. Ooh, this is going to be tricky. Here's sort of a path. If I can maybe get this trace out of the way, can I move that power somewhere else? I can kind of clear a lane up there if I go power across here instead of across there. Maybe I'll do that. So here up to here. Like via to there. And then that's too close to a hole, so let's move it a little off. Like that. And then I don't like that being too close to that other hole. Yeah, that's better. Okay, so then I don't need this trace, which is sort of getting in my way. Delete that guy. Let's move this via a little bit because I don't like it. There, I like that better. Okay, so now I think I've cleared the path through here. Through here, right? So if I go here and go left, then I've gotten a clear path. And then I just need to via up somewhere here. I need a lane. Like right here. Okay, let's try that again, because the V key wasn't working when it should have. It's getting like really confused for some reason. There it goes. And just do that. Although I just crossed that, didn't I? Okay, so let me fix that. Delete this last part of the trace. Have this go up to here and then via back. Then we can go across. Actually, I could have gone across before. Yeah, I could just still go across. I don't know what I was worrying about. Alright, so then we did the first leg, the first underglow pixel, and the second leg is we need to go straight up. Hopefully I have a lane to do that from. X, and then via, and then we're going to go vertical from here. Can I squeeze through here? No, can I squeeze through there? Yes. So we're going to squeeze, it's fighting me, but I know it can do it. There we go. We're going to go up. Ooh, we need to make some room here. This needs some room on right here. There we go. No problem. We made some room. All right, and then where did I leave off? Right here. So we're going up. We're going across. We're gonna go. I guess we'll go on the left or right. Left. Yeah, go left, and then via back to the pad, like that. Okay. So the next is gonna go across. All right. We have a pathways partly there. How come it doesn't want to go through there? There we go. And at some point we want to go up and then across again. So let's do a via here. Go up, via, and across. Easy. And this one needs to go down, right? So via, down. Nice, easy path. And then like a via here. Done. Okay, and then are we done? Unconnected. We're done. So I've connected the underglow LEDs. Now I just have one more daisy chain to connect, which is the per key LED, which is these are the rat's nests you see there. So I've arranged this so hopefully it's not too horrible. We need to go, the first one's just over there. So, and here, this is the last, since this is the last set of traces, I can throw all the rules out the window and just get there however I can, right? Actually, I see a path. This is easy. Just via up, via across, and down. Let's try that again. Via up, via down and down. Cool. And then the next one's here, and we have to go down here. So that means via and then up. Can I fit through there? I can. Sneaky. I can't fit through there though. Oh, maybe. Oh, I made it. I made it through. Okay, I don't like that. I need to make some room here. I can make some room here and then maybe make some room here. Yeah. So let's move the freeway here a little bit. Now we're getting close to our tolerances for trace to to hole, but I think we'll be fine. And then like some room here, please. If you please. How about we do that? There we go. Plenty of room, right? Would a multi-layer PCB help clean up the traces? You mean like adding 2 more layers? It would make it a little bit easier. But I don't think it's necessary because we're almost done. And there's still, like, if I really couldn't find my way through here, I could just do what I did over with these last 2 columns and just say, oh, let's just go around. Let's go all the way around to these columns, right? So, like, there's still plenty of pathways through, like, there's lots of room through various things. There's just some pinch points. And the pinch points are because of the holes, right? There's this cutout hole here, and then these light blue guys are also holes. So that's where those are pinch points. We don't really have a choice here. Even if we had multi-layer, these holes go through all layers. So they're going to be pinch points no matter how many layers we have. So it does limit the avenues we have. We have sometimes we can fit through, like here, we can fit 1 trace through that, but not more than 1. But between switches near these diodes, I have a bit more room. I can fit maybe 3 traces. And then wherever we have these mounting holes is also a pinch point, right? So there's not a whole lot of space to go between that and the other nearby holes. Yeah, and again, there are multiple layers will make it a little bit easier, but still we'd have pinch points. And don't think of me as an expert. I'm a newbie at this. If anyone in chat knows more about PCB layout, feel free to correct me. Did I just rot that one because it was easy? I think I did. Oh, yeah, okay, I was on this one, right? This one's next. Yeah, I routed this one because it was easy at the time. So, but we need to route this one straight down. Yeah, and I had given myself some room, right? So via, and then now we have some room to fit through there. And we just skirt alongside the other guy. Right? Got plenty of room. And then via back to the pad. Easy. So this one we already did. I must have seen that one and said, oh, that one's easy. This one goes across. Okay, there's not a whole lot of room to navigate here. I think what I'll do is I will go down to a via, and then I'm going to totally break my own rules here and shoot, I don't see it. Okay, let's try the other direction. From here we can traverse most of the distance by going through here, right? And then now we just need to get through that other trace there, right? Need to go. So why don't we just go via to frontside copper and go through here. And then straight down to a via right around there and then connect. There we go. So it broke my left-right side rule, but we can because we're fitting the last few traces in there. All right. Next is we're going up from there. Okay, we need to go up. So via, and now we're on the front side layer. Is there a path through here? Ooh, I can fit. Oh no, I can't. That one's troublesome. Yeah, it doesn't really want to fit. It's not within the constraints, so... Oh, right. We have a pathway through here. Let's go this way. Oh, come on. You'll fit through there, won't you? Not quite. Maybe it needs to go the other way. Like around that cutout and then up. Yeah, let's just take the easy path through here. And then via to the pad. There we go. All right. And then this one goes up. I don't have, this one's not giving me a lot of room, so let's make some room. like that. Okay, and then go straight to a via. Skirt around here maybe? And then up. Plenty of room. Just need to kind of guide it, right? And then via to the pad. Okay. It did a little funny janky thing here, so let's fix that. All right. I don't mind the traces being close, but I do mind even getting too close to that hole. If I can avoid that, I will. Like that, right? Give it more room around that hole. Okay, and then we're avoiding that. Actually, we can't move that one unless I move the whole diode, so that's fine. All right, next. We're going across. Across. This I can move to give myself some more room. So that here I can go... Oh, this is going to be bad. Can I go around this cutout? I can if I give myself some room. Like that, and then this moves even further down. I don't like that being so close to that hole, so move it away. Cool, so now we can go... I think we have enough room now to go around the cutout there. And can we fit through here? We can. We can fit. We need to go up at some point. I'll fix this in a minute. A via right there. Straight up. And where's a good point to switch over? Right around here. And then go right. And then fit through this weird thing here. Maybe I'll clean this up so I don't have to do that. Well, I can at least move the via a little bit to the left. Maximize the space between holes and pads, right? So like that can move, I don't know. It's probably fine where it was. And then sort of a pity that I have to do this little jaunt around this hole, but that's not via, but that's okay. All right, next. Down from here. So, via, and then we're gonna go right under this diode. We know we can't use that, but we can use this avenue around here. Perfect. Via to pad. I don't know why I drew that so far away. And now it's giving me trouble dragging it. Okay, just show me front side layers. Now I can drag it, right? Okay, now show me all layers again, except for the fab layer. Okay. Well, this one's going to be interesting. We have to go down and hit this pad, but there's this big round wire in the going through. Actually, that's wide enough where I can do the trick I did before, right? And widen that up a bit. And then this might have enough to squeak through here, go down, and like if I move this out of the way a little bit more, you can go down and then like connect back into here. If this was over, you could do it a lot more easily. How about I just do something like this? So actually I can just do it from the bottom. So my idea was there, and then okay, I need to get more room here. Okay, X. Yeah, so yes, go that way. Go that way. Sometimes it needs extra clicks for encouragement. It's like, yeah, you're doing great. You're doing it. You're going the right direction. like that, and then hide that for a second. This is just to avoid that hole, right? I mean, it's okay. We're avoiding holes, that's fine. This doesn't need to be so close at that point. That can be, we can use more space. There we go. Yeah, we got room. Let's use the room. Use the room where we have the room, right? Okay. So, the next one's from here over to the right. This one should be easier. Except for this thing, which I'm going to fix now by going to a via to that hole, because I can. What am I making? I'm making a keyboard. Project. So I'll zoom out and I'll show you. It's a split keyboard, kind of like a corn keyboard. So there are 5 columns and 3 rows on each side, plus 3 thumb buttons. This one you see on my second camera is like a little prototype where I was working out my bugs, because I had never made a printed circuit board before, and I indeed had some errors. So learn from this little intermediate board, which had a lot less soldering, and I'm just scaling up now to the full size 36 key keyboard. So most of the time I'm working on firmware, so the code that runs on these controllers to operate the scanning of the keys and then reporting them to the computer. Writing that all in Rust, so that's why it's the Rusty Keyboard project. But on a few streams I'm needing to do this hardware design, so that's what I'm doing today. I'm doing the copper trace layout of all of the circuit, basically. So there are 3 main parts of the circuit. There are the controller and the connector. So this is like a USB-C connector here, and this is a controller board. There's all those switches, so there are 36 keys, and then there are a bunch of LEDs. So I connected all of the controller, connector, switches, but I have not done all the LEDs. That's what I'm working on right now. So every key under here will have an LED to shine up different colors as you press them or whatever you want to do. And they all have to be connected in this, basically a big long chain. So it gets power and it gets ground, and then there's one wire in, and then they're daisy chains. So the output of each goes to the input of the next, and you basically push a pattern of red, green, blue values through the entire chain, and it lights them all up. Are those Arduinos? No, they are Raspberry Pis. So Raspberry Pi makes a microcontroller now. It's called the RP2040, and our Adafruit makes a little controller board called the Keeb 2040, which is pin compatible with Pro Micro, which is used on a lot of these open source designs for keyboards. So what is this, like 28 pin connector? And it's got a built-in USB-C, couple built-in LEDs, it's got a reset button. But the main thing is it's got a lot of general purpose IOs, and you need at least 7 or 8 to have 36 keys. You need 3 rows and 6 columns, or there are other arrangements, but you need a lot of GPIOs to connect to the whole matrix of keys. I think it's sweet too, that's why I'm doing it. Okay, so I'm basically connecting this daisy chain of LEDs, and these aren't like the picture depicts. They're not just one LED, but each one is a package of 3. So there's a 1 red, 1 blue, and 1 green, and there's a tiny little microcontroller in there. You can look this up, SK6812. It's otherwise known as the NeoPixel. It converts a special bit pattern of 1s and 0s that come in on a single wire into 3 bytes, 1 for red, 1 for green, 1 for blue, and that says what intensity to light up these LEDs, and then it takes care of the pulse width modulation, or other whatever technique they use to make the the illumination of these LEDs somewhere between completely off and completely on, so you get the exact color that you want. So, and also it takes care of the rest of the circuit, so I don't need to have any resistors. I can get away without having capacitors, even though they recommend it, because other keyboards have done this too. So it's really pretty simple. You just lay out this part, you connect power, ground, and then there's one signal from your microcontroller to like send in the whole chain of colors through. Love the NeoPixels. Yeah, I'm kind of liking them too. The fact that you only need one wire for the protocol, and if I just switch over to the software, there is a Rust crate that handles it for me. So over my keyboard here, I need to do, this is the onboard NeoPixel, this is the switch LEDs and underglow LEDs. I am using this WS2812 crate. So you just tell it what pin to use. You have to give it the programmable I/O block for the particular microcontroller, and you need to give it a state machine, you need to tell it what clock frequency, and you need to give it a timer, and then it takes care of the rest. Whenever you want to light something up, you just say, I want to write this color with this brightness, and if you have a chain, you just, instead of saying there's only one color, you'd have like a sequence of them. So it takes an iterator, and it takes care of all the timing and everything. I think this write is a blocking call, so it's clocking out the bits until it's clocked out everything that is encoding this string of colors, or in this case just one color. And by the time this write function returns, the LED state is changed to show the color and the brightness that you want. It's pretty easy software-wise. Didn't have to write any of it. It's written for us. Okay, so I'm connecting my daisy chains. I'm up to, where are we? NP27. So I've gotten all the way down the chain, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more to do. I've already done the left-hand side. We're halfway through the right-hand side. So here we have to connect there across. Oh, right. And I was going to say, I wanted to fix this ground wire, right? Delete that ground wire, and I think I'm just going to take advantage of the fact that we have a front side copper trace here and just go across and connect it there. Because then I can go here and just go straight across. Right? And then I do have to cross that ground there. Oh, I have an idea. You know what I'll do instead of connecting there? I'll delete that, and I will actually connect down. Come on, work with me here. There we go. I'll connect down and go straight like that. And then so that this, see how sneaky I was there? Then I can connect that up. And they kind of go around each other. Isn't that cool? There we go. Make it look nicer. Hey there, Endorn. Endorn, did you know that your name is on my board? Extra thanks to you. We don't have to, we won't see that trace, but this is what it's going to look like when we print it out. I appreciate my mods by putting their names on my board. Yeah, you're also on the prototype board, right? If you look really closely here. Okay, it's not coming into focus, but yeah, that said, thank you, Endor and Sarian also. But why didn't you connect ground to the right side to the red ground? Did I miss something? Hey there, War Eagle, how are you doing? Hey there, Smikolov. Yeah, maybe, did I make a mistake here? Show backside copper. What were we looking at? This ground here, you mean? Why didn't I connect the ground to the right side of the red ground? Oh, because I wanted a path for this signal line that doesn't cross the ground. So I didn't need an extra via. I need at least one via here, right? Because these signals need to cross each other. Just wondering, because you get rid of the crossing? Well, this has to go this way because there's no... it's hard. This signals, and these signals are all in my way, so I chose to go down here. So right now it has to wrap around, so now they have to cross, right? They have to cross somewhere, so I decided to have them cross right here, rather than have, then I only need one via and just place it down here, because there's a lot of room down here. So I guess I don't see how I could avoid the crossing. The only way I could avoid the crossing is if this one actually went up and around and took a different path to reach over to here. I guess. I might be missing something. You're probably seeing it and you're like, Raimu, why don't you see? Why don't you see it? It's quite possible that I just don't see it. You might be thinking that I could take a front side copper and just go straight over. The problem is that this pad is only on the back side. Maybe you're suggesting that I just have this via up here and go straight to the right. I mean, I could do that. It's the same thing, but it takes this hole dangerously close to these two, the pad and the trace. But you're saying that I could just do... I think this is what you're saying, right? Just do that. I still have to have this via because I need it eventually to reach either this trace or this ground. This ground I can go from the backside copper, but we still have the same problem. I can't actually get there. Oh, we can't go through here because this is a cutout. This is where the LED shines through the board, so I can't go through there at all. So I have to cross at some point, right? Thought there was more space to the left of pad 3. Oh, right here? That's way too narrow. In fact, there's going to be a lot of solder blob here. I don't want to put a trace there. Yeah, and this is a cutout. Kind of hard to see, but if I show you in the 3D viewer, it's more obvious. I forget, does this show traces? Where are we exactly? Hold on, we're on switch, I don't know. Near NeoPixel 28. Which I don't know where that is. Near this ground hole, right? Yeah. So there's the cutout because there's an LED that shines through the board there. Right, there it is, surface mounted on the back side. So we can't put a trace through there because there's literally a hole in the circuit board there. And I don't want to run a trace here because there's on the back side because there's a lead and a copper, a solder pad. There's a pad with solder paste on it. So I can't run a backside trace there. I could run a front side trace there, sure. That's like, I could run one of these guys. Fine, I can run that anywhere around here, right? That's fine. This I'm most comfortable with. We're gonna have to crossing will cross there, and then this will switch layers there. No, that's fine, War Eagle. It's actually a great exercise because I'm probably missing things here and there. It's fine to double check. Okay, so this I want to go up, right? I go pretty far up. This shouldn't be too hard because front side copper can squeeze through here. Can't it? Oh no, I've had trouble going through there in the past, right? So I've been generally going around to the left. Go around to the left and then, yeah, we just go to, can I just, okay, I'm going to break my rules a little bit and go horizontal with the front side copper. Via to there. I'm going to have to move the silk screen, by the way, because we don't want silk screen on top of vias. All right, another one going up. So via, and then same thing. We leave myself enough room here. No, okay, I need more room. So hey, Trace, could you move over a little bit? All right, and then we have more room now. It's fighting me. There we go. And then I'll just go up to here and then via to the pad. Okay, cool. So this has got to go across. Ooh, I blocked myself there. That's not good. And I blocked there. Okay, how to make it through this mess? Via, and then another via. I hate doing this. I think I blocked myself horizontally there. Well, what's better here? What if I work myself backwards? So we'll go this way first. This should fit through there, yes. And then where do we go? Up. I can actually skirt around here and go up from here. There should be enough room through here. Yeah. And then up from here? Okay, this is, then I just need two vias, right? So one like right here, and then one here. All right. It's messy, but we're getting down to that point where we're almost done. We can afford to be messy. Let me clean this up a bit. Come on. It doesn't want to drag. Why don't you want to drag? It's like really sensitive on this point. Okay, there is better. Because I want to make this a little bit cleaner. I mean, does it really matter? I guess I don't really... It doesn't really matter. Well, let's avoid the traces being close as much as we can. We're squeezing past some holes here, that's fine. Alright. Alright, next, we're going straight down. This should be an easier one, I think. Skirt around this diode hole, and actually we'll just go this way. And right here. Easy. And then down again. Hey there, Sarian. Save before crashes, thank you. Thank you, MVD Dev. Hello there, Control U Buyer. How are you doing? Must have neat traces. I'm kind of, at near the end, I kind of give up on it being super neat, at least until I get it all routed, and then maybe I'm like, oh, now I can take a breather and clean it up. Like, at this point, I kind of get just happy whenever it just routes correctly. Okay, this I can't stand for, though. That needs to look better. Just certain things, like, you have standards, right? And they just have to, at least be meeting some minimum standard. Like, why am I so close to that hole when I don't need to be, right? I'm giving that hole a wide berth, and I kind of want to, like, make that even, and then this needs to be kind of even. Yeah, this is pretty good. All right, next. Where are we going from here? Oh, we're almost done because we only have 3 left to go. So now we're going just all the way to the left. So these should be real easy if I design this right. Just skirt all, yeah, super easy. Look at that. I don't know why it wanted to go that way. That's much easier there. And then I already did that one because that one was super easy, and this one should be easy too. Hey, look, we're done. We have 2 unrouted traces though. I missed 2 somewhere. What did I miss? They're unrouted somewhere. Let's hide copper for a second. I'm looking for unrouted traces. I know what we can do. We'll use the design rules checker to find the unrouted traces. They are through a hole to pad 2. Okay, right. Oh, yep, that's unconnected. I missed that one. This diode connection. Okay, and unfortunately we have some columns running through there now. How do I want to fix that? Because I was using backside copper for all those close connections. Well, I could reevaluate my use of this pathway through here. It's a pretty long path, though. Well. True handmade, yeah. There are auto routers for this kind of problem, but everything I've read online says don't trust them. That sometimes it's just better to do it by hand. Never mind that they're barely visible in the final product, you'll still know. Yeah, whenever I look at the printout of this, I'll know. I'm thinking about just giving up here. Giving up consists of me just saying, okay, via to that pad. Ugly. Okay, where's the other unconnected one? I bet it's another diode. Yep. Okay, this only has one trace through it. And okay, that can go up, right? So let's just delete that track and move this via up, and we'll go above the diode instead of below it. Is there a trace there? Why is there a copper there? I don't know. But yeah, we can just go across from here. And then I suppose leave that where it is, and then just connect. Done. 0 unrouted. We're done. So I still have errors, but I was looking at this before the stream started, like last night, and they all have to do with okay, there's a legitimate one. All the ones I was seeing before had to do with the rotated ones, like this. It doesn't like these pads being close to this edge cut, but I think it's only because it's rotated, and the design rule checker, I think it's just taking the bounding box. Because if you take the bounding box, the bounding boxes, if you like horizontally and vertically draw them, like this corner does intersect this corner of the bounding box, but it's not. It says actually 0, but it's not 0. It's only 0 if you do a dumb like bounding box intersection. How do you figure out the PC board is working? That's a great question. So you can run this design rule checker to make sure you didn't do something stupid. But ultimately, the only way to know if it's working is you have it printed, and then you use a multimeter to make sure that you didn't accidentally connect power and ground together, and that all the signals are connected from the component that it's basically the signals are connecting components together. So you use the continuity checker on your multimeter to see, are they really connected? So that's the first thing I do when I get the board printed and sent back to me, is I take out the multimeter and I make sure power and ground are not connected. If they are, then you're dead. You have to start over again. Not completely, but you have to go find out where you made the mistake. After you make sure there's no short between power and ground, I just make sure all the connections, like from the microcontroller, well, it's easier to show in the schematic, right? Where we have these GPIO, so you put one end of your multimeter on like GPIO 10, row 0L, and then you go to each switch on row 0L, like switch 1, switch 4, switch 7, you make sure they're all connected. And you're basically you're verifying that the PCB faithfully produces these virtual wires to match your schematic, if we trust that our schematic is correct. So fortunately, a keyboard schematic is pretty simple. We just have the same pattern of row column with diode and switch repeated horizontally and vertically, right? So silly mistakes could be I accidentally put a column where a row should go, or vice versa, or I have maybe row 1 repeated, you know, they're not, if I have a gap or a repeated number here somewhere. And the checker, where is it? Is there a schematic checker? There's an electrical rules check we can run, right? Oh, I didn't mark that no connect. Oh, that's a legit thing. What's this? Symbol has been modified in, okay, no, but those are okay. But yeah, these checkers that you can run, make sure you didn't do something dumb. Power output and power output are connected. Oh, those should be power inputs, not outputs. Okay, so these are things I should have run and checked, but it's because I mislabeled them as power outputs instead of power inputs. But as long as we didn't accidentally, it's like one mistake you can easily do here is you might connect power and ground together. Like all I need to do that by accident is to draw a wire from here to here. Oops, power and ground are connected now. What that does is when we go to the PCB layout, it'll insist that it's the same network, or it actually might just complain right away saying you've connected two power lines together. So, short, I know that was too long of an explanation. Too long didn't read explanation is you only really know when you get it printed and you check to make sure the signals go from the places that you want them to go and they're not short-circuited. But there are a lot of things along the way that help you detect that early. Like there's built-in rules checkers that I'm running, both in the schematic and in the circuit board layout. And if you did a careful design of the schematic, and in my case, like it would be just looking for errors here, as long as you don't find any errors here, then the tool makes sure that the schematic and the PCB agree with each other. That catches most things. Like when I printed this circuit board out, the only error that I had was I had the symbol for the LED mirrored by accident. So instead of mounting these LEDs shining through the key, they're actually shining out the bottom. But everything else worked the first try. So yeah, let me just say I was very happy when I got the board back and it did not have a short circuit in it. But let me fix some of these errors. So these ones on the diagonals, I think these are to be, if I could mark them as I know and it's not really a problem, I would. But right now I'll just ignore them. Right? Those ones are okay. And all the ones that are on rotated parts are probably okay, right? This is kind of like inspecting warning messages on a compiler. We're just saying, yeah, the compiler doesn't like it, but we didn't do anything wrong. So again, this is saying that this edge cut and the silk screen are intersecting, but they're not really. Right? Same thing here. Okay, here it's saying that my trace got too close. Okay, clearance is 0.35, actual is 0.35. It's saying that I'm like at the we're a little bit too close. So what I could do here is give it some room. So let's move this trace slightly up if we can. It's not going to want to let me. I might not be able to clear this error because I can't move that trace any far up without getting it too close to the other trace. Unless I choose to route this differently. Actually, what if I do that? Let's be nice and route row 0 around the top instead of the bottom. I'm going to do it by kind of making a wide junction there and going through here and there. Try that again. It did something funny there I didn't like. Through there. Yeah, see, it's doing that weird V there. I don't know why. Okay, now we have plenty of room for this trace to be dragged up. We'll just drag it up so it's got a lot more room. Then we'll run the design rule checker again. So going from 17 errors to 16. Let's go from the top. Okay, it's saying that this red trace is too close to that edge cut. So we can drag that, right? We have some room. We can just drag this down like that. Run it again. We should have 15 errors. Right. Next one. It's saying that that blue trace is too close. So again, I can just take this and drag it a little bit further away. So we're basically giving ourselves more margin between a cut and a copper trace, right? And there's another one. And it technically wasn't an error. It says clearance is 0.35, actual is 0.35, so it just doesn't like to be exact. It's probably a floating point error, right? Comparing two floating point numbers, sometimes they're never exactly equal to each other. Okay, this is saying that board edge clearance violation between the edge cut and a via. So my via is too close. In fact, it's less than the clearance, so it shouldn't have actually let me do that. But that's easy. We just move the via a little ways away. I do need to make a connection between the via and the copper, though. All right, and then should that be down to 11 errors now? Yep, down to 11 errors. Okay, another trace is too close to a cut. So just gently, without disconnecting it, gently drag it away, run the checker again, down to 10 errors. Okay, so these are all the diagonal ones that I don't care about, right? Yeah, it doesn't like that edge cut being so close to these things when it's rotated. I'm gonna ignore that. Cool. So then no unconnected items. So we're good. There were some of those weird errors on the schematic. Let's go back and fix that. Oh, a lot of them had to do with the controller being they're marked power outputs when they should be inputs, right? So that's symbol editor. Project. KB2040. Yeah, see their power outputs? I really should mark them as power inputs. Yeah, because technically the power is coming from the computer, not the controller, right? This is not a power supply. This is a power user. So these should be all power inputs, not outputs. Well, 3.3 is a power output. I'm going to leave that the way it is. Raw is the power input, the 5 volts from the PC. Ground also comes from PC. So yeah, this is now correct. So what I got to do is I got to go to the schematic. I got to do update symbol from library on both controllers. Now when I run the, what is it called? Electrical rules check. Yeah, now it's not gonna, it shouldn't complain about the controller anymore. What's it saying? Oh, I did the same thing with the NeoPixels. Is that because by 5 volts is not a power output? It says error input power pin is not driven by any output power pins. Why is it only on 43? Why doesn't 42 have the same problem? That appears to be connected to 5 volt side 2. Is it trying to tell me that this isn't connected? I mean, it looks connected to me. I don't know why it complained only about that particular pixel. Well, NeoPixel 43 is here. And I did connect its power and ground, so there's not anything wrong with it. It just doesn't like... Okay, let me fix these other ones. These should be marked no connect. So when I mark them no connect, run the ERC again, now there's no errors there. Okay. Interesting. It's complaining about some of them, but not others. I don't know why. Okay, how about this one? Warning symbol plus 5 volt 2 has been modified. What does that mean? Modified. Modified. I don't know what that means. Warning symbol plus 5 volt dash 2 has been modified in library project. Does that mean I need to do like Update from library. Maybe that's what that means. Update symbol from library. Now let me run it again and see if it still complains about it. Yeah, that's all it was. So it just says that the symbol in the library has been updated, and I just need to update it from the library. So let's do it. Yep, okay. I don't mind telling it to update from the library because I want them to be in sync. Alright, run the check again. Okay, so I need to figure out why I'm getting this error. Input power pin not driven by any output power pins. Let's go to the symbol editor for that NeoPixel. Maybe I did a mistake there. Let's see, this one. Power input. What about the other one? Also a power input. Power input. Okay. Could it be in my 5-volt one? Oh, why is that a power input? Is that the problem? Yeah, okay. This needs to be a power output. Power output. I bet that's what it was. Power output. And probably my grounds that I made. I had to make 2 different grounds. Oh, wait, no. I didn't have to make 2 different grounds. The grounds, they already had them, right? What am I using on the schematic? Ground 1, ground 2, right? So ground 1, ground 2, I think already are already power outputs. Okay, that's the problem. Okay, so then I need to update all my 5-volt ones again. So now there are power outputs, not inputs. Let's update all symbols matching the designator. Matching the value. Okay, cool. So then run electrical rules check. Okay, so I still have some that didn't get updated. Don't know why, but I'll do them manually. Really? Wait, that one I updated for sure. How come that's still showing up? Update symbol from library. Update selected symbol. Do I need to update reference? Oh, value. Let's just update reference and value. Maybe that's what I did wrong. Wait, what's the annotation dialog? Oh, I might have some references unannotated. Huh. Did I not save? 5-volt plus 1 plus 5-volt 1 and 2. Power output, okay. And then update selected symbol, updating everything. Update reset symbol attributes maybe? It says it updated it. But it still says it has been modified in library. Okay, then what if I just delete it? Delete it and add it again. Plus 5-volt 1. Alright, and then run this again. No, it still says it. I don't understand. Whoa, what happened there? This one's still saying that it's not being driven by a power output, but it is, unless this is not being updated. What happens if I hit edit library symbol? It does go to that one, right? Yeah. It's symbol from library. Let's just change hit all these. Reset fields. Okay, let's just hit on them all. Okay. It did move that. That's okay. Run it again. No. Okay, I can't resolve that one for some reason. This was working a little bit ago. Why is it not working now? That error went away. Okay, so I'm down to just around these underglow LEDs. It's saying that the symbol's been modified. Okay, and it's also complaining about the ones on the connectors and the keys. But that's weird. Under just this one? Okay, now the warning count is down to 3. I don't understand why. Sometimes it updates and sometimes it doesn't. Okay, well, it's actually updating it now. I don't know why it wasn't before. Down to 1 warning. No warnings left. We just have 2 errors. It's saying it's not being driven. But it should be driven by this ground. I don't know why it says it's not being driven, but it is being driven. Okay, then what is this if it's not a power output? Value ground 1. I just need to update it? Was that it? I need to update this one too? Nope. Okay. It moved. I think it moved. Let me try updating this symbol. Okay, that reset the... I don't want to do that because it reset the designator. What if I turn off reset... reference? Now run ERC. No, that didn't fix anything. Okay, I don't know why I'm getting these errors. We're down to 2 violations. And I don't understand them. It's saying that they're not driven by any power output, but ground 1 and ground 2 are power outputs, so I don't understand why it doesn't think it is driven. Okay. Edit symbol, maybe? Wait, why is it power input? Wait. Is the library symbol power input? Oh, it is. Why is ground 1 a power input? I don't get that. Maybe I don't understand what a power input is. Ground should be supplying, it's supplying the ground, so it should be power output, right? I hate to modify the base library. Okay, what is it? What is like plus 5 volts, for example? Power input? Do I have these all backwards then? Power just flow into it? Well, actually, it's the other way around. The electrons flow from the ground to the positive, right? I don't know. It depends on what the meaning of input and meaning of output is. What's the... And why does it only complain about those two? It didn't complain about any of this. Okay, well, let me look at this symbol. Edit library symbol, right? Is ground there? Why is it marked passive? That's not even correct. Why would you mark them as passive? Do I need to do the same thing on my symbol? Hold on. It didn't complain about this one. It's power input. I don't understand. How about... Power input, yeah. I don't get it. I guess I can, there's like a way you can mark something with the power flag. I mean, I guess what that is, but wasn't there another way to mark it? Hierarchical label, global label. Was it power flag? Power flag. Special symbol for telling ERC where power comes from. What happens if I attach a power flag to there? Okay, it does fix that. I hate doing this though. Excuse me. We're just attaching power flags saying that there's power there just to satisfy the ERC. Well, was it worth it? We got 0 errors, 0 warnings now. It shouldn't change the PCB at all. I guess I'm just gonna stick with that. So there are power flags on our 2 grounds. So that reinforces that that's a power is provided there. Okay, let's go to here. This shouldn't do anything, but let's do update PCB. And then DRC. And now I have 68 errors. What happened? Wait, what? Oh, my power got removed. How did that happen? Off these connectors. That got disconnected somehow. A4 and B9. Wait, how come it doesn't show B9? This got disconnected somehow. Yeah, these nets got changed back to J2 pad A4. J2 pad, okay, let's just delete that then. And we'll just add it back. Plus 5 volt 2. And then update from schematic. Okay, why is it not getting the net correct? It's J2, right? Yeah? I don't understand. I screwed everything up. Did something to the power. So that net is different now. Let's try deleting. Oop. Deleting this and adding it again. Okay. Nope. It's still messed up. Okay, maybe I should just undo it then. Okay, I undid it and then plus 5 volts is back. But I'm gonna have a problem where if I update from schematic, it's going to remove my power. Okay, I gotta fix this. Something's wrong with this plus 5 volt 1 and 2 now. Maybe it's the reference is different. Power 0107. I bet that's what it is. Yeah, okay. They're different. It thinks that they are different instances somehow. Okay. Yeah. So then how do I fix this? I think I just place it. Okay, let's try placing it and then copying it everywhere it's used. So I'm gonna delete the power. Delete plus 5 volts everywhere. Hoping that ground isn't screwed up. It didn't change ground on my PCB, so I'm hoping it's fine. Okay, so ground is deleted everywhere. So let's add ground, add 5 volts back. So we'll add it to the controller first. There. Now I'm going to copy it and paste it on, this is the left side, right? So left side keys, left side underglow, left side connector. Okay, and now I'm going to add the 5 volts 2 to the right hand side. And right hand side keys, and right hand side underglow, and right hand side bus. Alright, now electrical rules check. No problems. Actually, it had a warning though at the top, right? Now it doesn't. Update. Nope, it's removing the net. I wonder if I screwed it up, like the net class is screwed up or something. Yeah. Yeah, okay, so it's really confused, right? It doesn't think it's the same net anymore. I kind of feel like I should just hit undo until we go all the way back to, not having the power flags anymore. Wait, what's the difference there? Let's go back to before I, added those no connects. There we go. Save that. Updates from schematic now. Power's back. Run DRC. Okay, now we're good again. Only problems are the diagonals. Okay. We're just gonna have all those electrical, what is it? Oh, click the wrong thing there. Electrical rules check violations, right? Maybe I just ignore these? Because I was getting into trouble the moment I mucked with these, right? Okay, I know what I'm gonna do. I'm gonna check this into Git before I do any more other changes. Autosave files, I don't think I need that one. Beep beep. What's autosave files got in it? Autosave, I don't think we need that. Let's close everything. Check this in. Refresh. There we go. Okay, check in all this stuff, right? Right, I added those. Okay, so I did a bunch of stuff here. It's been too long since I checked into Git anyway. Okay, so this is nearly finish. Full 36 key keyboard. So add Ferris and Rust logos. Those are those two things there. What did I change here? Okay, here's where I went into the library. Maybe I just toss these changes for now. I think I'm gonna toss these changes. Where I changed things from power. Actually, those were power outs to power ins. Why did those change? Oh, right. That changed on the controller. Maybe I'd toss these for now. Actually, I can keep them. I can see them in the Git history. Okay, I'll keep these. I think these are what they should be. Well, maybe not these ones. I'm gonna keep them. Okay, so everything. So this is change plus 5 volt 1 and plus 5 volt 2 symbols to be power outputs, and then change plus well, it's raw and ground pins on control or KB 2040 to be power inputs, and then it's rearrange all under, well, what have I been calling them? Key LEDs on right hand side. to well, replace to be easier to be consistent with the left-hand side. And then we did all of the route all signals on right-hand side. Okay. Now that I have like a checkpoint I can go back to, which I should have done before I screwed with the thing in the first place, I can try again to fix the electrical rules violations. So let's run the ERC. It's saying that the symbol's been modified. So let's start with this one. What if I just update from library? Actually, with it, instead of updating, what if I just delete it and add it back? What happens? Now, let's see what happens if I just update the schematic. Let's see what happens on the left-hand side here if these nets get damaged. Yeah, okay, that screwed with those nets. Just removing it and adding it back screwed with it. So undo, update. So the library symbol change is bad. Okay. How do I... so do I need to undo that change then? So the change was... okay. The change was in project, marking them as power outputs, right? So flipping back to power input again. Okay, and then back here. Now delete it. Add it back. Go to PCB. Update from schematic. Okay. That's what killed the net, was changing the symbol to be a power output. Okay. So then what does that tell me? I need to fix those rules differently then, right? These input power pin not driven. So I think I just use a power flag to fix that, right? Okay, this I need to update, right? So delete. Let's just delete it. Delete it and add it back. Plus 5 volt 2. Hey there, Cargo Clippy. Very nice name you have there. Okay, that. Save. And here, let me update, make sure I didn't screw up the net. Okay, the nets are still good. Whew. Hey there, Meme Clear Bams. How are you doing? All right, then are we down to one warning? So this one needs to be refreshed. I'm just gonna do this. This seems to be safest to just delete it and add it back. And then make sure that the net doesn't get screwed up on U1. So that shows up right here, right? So updates from schematic, still good. Electrical rules, check. Okay, so no warnings. Now we just have errors about these, and I solved them before by adding power flags, right? And I don't know why I have to do this. But if adding power flag solves it, then I'm just going to do that, right? There, we've added power flag. So I need to add power flags on the other side too. Right there and there. Actually, can I just add them here? I'll move it a little bit. I will just move these over because I have the room. What happened there? Oh. Interesting. So let me add that back. I think the label got moved or something. Yeah. Oh, it's moving it by itself. Why isn't it only doing that for one and not the other? Oh, okay. Well, now it's consistent. So DRC or ERC, 0 warning, 0 errors. It says schematic is not fully annotated yet. But at least we have 0 warning, 0 errors, and I can update this. Doesn't destroy anything, right? It doesn't kill any of my nets. The only errors and warnings we have are due to the diagonal shaped cuts, which we're ignoring. Okay. We're in a good state now. So, what did that mean when it said, see, now it's not saying it. It said something about annotations, right? I don't know what. Maybe I'll wait until I see that again. Was it, how about we close that, go back to the schematic and run it again? No, now it's not showing up at all. I don't know why it's doing that. But I think we're good now. Oh, I closed that too quickly. Let me double check through all of these that it's just if it's only on these diagonal shapes, then I'm not going to worry about it. Yeah, these are not real errors. It's just the checker. I might want to move that trace though. I'm gonna look for yeah, okay. So I'm done with that, but I do want to do some manual cleanup here, like that trace being so close to that edge. I don't like that. So I'm gonna move that away. Okay, and now I'm just kind of going around the board looking for stuff like that. Like this, we can afford to like move this further away from that edge. This doesn't need to be so close to that edge. It can like be even there. This too, I don't like that being so close. Yeah, I should clean this up a little bit. We're like splitting the distance basically. Hey there, Endorn from work location. I'm basically done, Endorn. I'm just going through and looking for like last minute, well not last minute, I'm looking for things that could be improved like this, for example. It doesn't need to be so close to that hole. Oh, I should also make sure all of the silk screens are not obscured by cuts. And if possible, well, actually, silk screens can be on top of copper traces, right? So I don't need to worry about that. But I need to double check the silk screens. I think right now I'm looking for places where traces are too close to edges and holes. So like here, I want to split the distance between this hole and this edge cut. Like right here, that might be getting too close to that. And I have room to spare here, so what is the distance there? grid to 0.01. What's the distance from there to there? 0.41 millimeter. And how close do we usually get? 0.41 millimeter. Okay, so it's fine. I won't worry about that distance. I'm just looking for things. How about we just do, so I don't get confused, let's look at front layer only. So we're looking at red traces. Kind of close to that. We don't need to be. Can we just move that? Sure, I can move it. This unnecessarily close to that hole, right? That's unnecessarily close to that edge cut. Let's get some clearance from that hole there. Same thing here. Yeah, why don't I just do that? Here we're getting kind of close, but I have a lot of traffic here. I don't want to move any vias yet because it will break the connections to the copper on the other side. But I'm thinking, like, if I can move all of these vias a little bit to the right, maybe it might be nicer. Or I can move this diode to the left. Hey there, Everix. Do the people who print the board say what the minimum distance? Yeah, they do. And I took their distances and I added a tiny bit more to be conservative. I think probably I'm being too conservative, but I spend money whenever I have them printed, so I'd much rather be over conservative than under conservative. That's really close there. That might not be good. That might be a problem there. Shoot. Well, there aren't too many things. Let's look at all layers then, or all copper layers is better. Yeah. We can move these a little bit. Let's move this guy. Actually, I don't need to move that via. I could just move the trace. This trace can just move a little bit to give me more room. Right? Splitting the distance between this hole and this via. This via, though, I want to move. That's like too close. So let's move that. Is it safe to put a via between? Oh, this is actually under. Going down. That's probably fine. Okay. Not gonna worry about it. Come on, move, move. There we go. I want to drag this a little bit. Oh, that's bad. I want to drag this a little bit to the left. Well, actually, that can stay where it is. It's this one I'm concerned about, right? That should be more like that. There we go. So I've cleared that through hole, the plated through hole, right? Okay. This is hard. No reason for us to be so close to that edge cut, so we're moving away from it. This is kind of sharp, right? Wouldn't it be better to just put that up there? Hold on. Yeah, what am I doing here? That track doesn't need to be there at all. We can just move this to here. There, much cleaner. I don't know why I had that extra trace there. Okay, moving on. This is unnecessary. Sometimes it depends on where you drag the... Oh, it's because it's this one. I need to move this one first. There we go. Yeah, it's like, move! Exactly. Yeah, JCB PCB is who I went through first, and they didn't send me any questions on the first prototype. It printed just fine, like, no issues. Let's put that via right there. Okay. I mean, this looks nice. Just looking for things that obviously could be drawn better. Why do I have it go down there? Oh, I was avoiding putting a via under that part. That's why. So let's also show user drawings. Yeah, so I'm avoiding going on that LED. That's why I did that. Actually, I should try to avoid it on all of them. This one, though, I had trouble, right? Actually, I could move that via over to there. Now I'm not under that part anymore. There we go. Just avoiding putting vias under parts is... I think that's something you should avoid. Not entirely sure. Here's another part there, nothing wrong there. Do I need to move this? This is a very high traffic area right here. This could be moved a little bit. This could be moved. Easy, exactly. I mean, I don't see anything too bad now. Should I flip over to the other side? Let's flip over to the other side. Okay, here's a via. Can I move that around? Yeah, it doesn't need to be there. It can be up, right? This could go up here. No higher than there. And we should move... This should be connected to that. This should move over there. Fix that. And then fix this. Like that. Alright. Well, how do these get so close together? That needs to go there. Okay. Glad I looked at this area. I don't know, do you guys think I'm being nitpicky now? I don't want to pay for the board twice. I'd rather get all mistakes sorted out, like, now, rather than, like, having a problem and then it being something I could have easily avoided, you know? You only recently learned about ASML, even though you've been a tech enthusiast for decades? Must pack in all the vias. Oh my goodness. Well, yours looks nice and like straight. Yeah, yours looks really nice. Train track diagram, yeah. I like the diagonals. I don't know about you guys, but I really dig the diagonals. Okay. This, we have a little bit more room, right? Trying to split that distance between the hole and the through hole. Okay, I got a weird little jog here. If I move this one down, I won't have that, I won't need to do that little jog, right? Well, that we should do. But this, I don't need this anymore, right? This can go straight. What happened to... What happened there? Why is that little segment weird? Okay, anyway, fixed it. Okay. Zero unrouted. I'm looking at the bottom here where it says number of unrouted unrouted nets. That needs to stay at 0. If it's not 0, that means I made a mistake somewhere. Oh, I know. I remember why I did this. I'm trying to avoid these holes. Yeah. This one could be, this little bit could be moved though. Sure. Why not do that? Okay. There's no reason to get so close to that hole there, is there? Let's move it away. Do I need to be worried about getting too close to this edge? How close am I? I'm 1.5 millimeters. That's plenty, right? Yeah. Okay. Huh. I didn't need to do that. Look at that. I didn't need a path through here, so I can simplify this greatly. I don't need the measuring tool. I can just delete this. I can delete the vias. And delete that, and then just go straight from here to here. Right? Might be other places where I have, like, unnecessary vias. I should be looking for those too. Don't see anything else. Oh, here's one that doesn't need to be so close to there. Be more like that. Well, yeah, fine. Really should like be right in the middle of the, yeah, okay. I'm just kind of like randomly looking for things that stand out. Like that doesn't need to be so close, right? We have room. Might as well use the room we have. That looks off. Yeah, center that. Okay. This also looks off. That looks unnecessarily close to the edge cut. This one's off. Mm-hmm. We have more room here. Why don't I move this via down to here? Plenty of room. Oh, and I wanted to avoid having vias under these parts, right? So let's just put that up here. Okay. That's weird. Oh, right, because we're trying to avoid that hole. I can do that maybe. I mean, that looks more aesthetically pleasing. Okay, I think I'm down to nitpicking. I should just like make the Gerber files and send this to JLC PCB and wait a week for it to come back, right? At this point. Or wait to see if they have any questions or concerns about the board. That's fine. Oh, that might be a problem there. That's too sharp. Let's go at this from this angle. Why is... Okay, that's better. I'm wondering why that wants to connect there, though. I'll just delete that. There's like extra tiny tracks here. that don't need to be there. Yeah, I don't know why it did that. Oh, hold on. I just noticed the width got narrower. I think my nets got changed. Like they're not in the power net class anymore. Let me fix that. Yeah, these got taken out of the power class. Net class. There we go. Because I want my power and ground traces to be a little bit longer. Nice and thick. Thick trace. Yeah, I don't know why it wasn't centering that one up. There, looks better now. Diagonals look pleasing? Yeah, I agree. Yeah, this is probably fine, right? I keep thinking of different perspectives to look at. Like now I'm thinking instead of looking at the traces, my eyes should be going to the vias. And like, for example, this via is kind of close to that pad and it doesn't need to be, so like, why not move it away? Right? Like, it can be down here, right? So it's away from that pad now. Why is that via there, right? Couldn't that via just be right there? Yeah. Okay. This has got some room, so why not move it there, right? Okay. This should be cleaner right there. We have some room here, so why not put it like right there? Like, no reason not to stretch that out a little bit. Same here, right? This can be moved a bit. So I can, like, give this via some more room. And then clean this up a little bit. That looks more pleasing to be like that. Okay. There's nothing against a 90-degree angle if we go through a via, right? It's only if it's a 90-degree angle on the same layer. Okay, again, this could be dragged out, so I can move that out a bit. And then no reason why that can't just go diagonal like that. Okay. Yeah, I want to give myself a lot of room around these pads. Unless there's a reason that I can't. This is a weird connection right here. Either way, it's weird. These red look thinner than the others. Yeah, they're signals, not power. So the power ones I'm making thicker. I'm making it 0.35 millimeter, and the normal signal ones are only 0.25 millimeter. And I did that because a couple of the online hints and tricks about layout said that if you can, you should use wider tracks for power so that you don't have as much resistance on those lines when there's a lot of current flow. So signals carry very little current, but power and ground tend to carry more, so might make them fatter if you can, right? We can afford it. I can bring this one further out from that pad, and then this one too. Yeah, well, if you see the G and D and plus 5 volts, that's power. And these random nets are because I didn't name them. They're in that daisy chain, so there's going to be a lot of unnamed nets in between these neopixels because I was lazy and didn't bother naming them. But and if I named them, it'd be something like daisy chain between 4 and 5, daisy chain between 5 and 6, something like that, right? And if I'm zoomed out, you really can't tell which ones are power and ground. But that was another thing that the guide said, that it also helps you identify from a glance what's power and ground. So like this thick trace next to this thin trace tells me that that's probably a power line. Yeah, it's ground next to a signal. All right. It's past midnight. I should try to wrap this up, right? And like this, there's no reason for this to be here, right? We might as well put it way out here. And this can just be moved up to there. This via, let's put it a little bit higher. Oh, deeper red? Yeah, I think we can change the colors, right? I don't know where you can change it from, but yeah, it's just telling you which layer they're on. So yeah, red is on the top, blue is on the bottom, and these through holes are plated with conductive metal. So they're like channels between the layers. So you can just think of them as connection points. They're called, if they're tiny and they're only for traces, they're called vias. If they're wider, they're usually because there's a hollow part for things to go through. So these are for the pins of my diodes to go through. And the even bigger ones that aren't plated are just normal holes cut in the board. In this case here, this is an edge cut. So a saw comes in and cuts out that shape. Like these are drilled, I think, and these are like milled. That's my understanding. Okay, there's no reason for this to be so close to those vias, right? Put that way out there. We can afford some space here, so this can move there. Sure, leave that the way it is. I'm kind of running out of things to look at, which is a good thing. Let me make sure I didn't violate any new constraints. Nothing new. No news is good news. There's probably more things for me to check and fix. So maybe I should sleep on it and then look at it again tomorrow, and if it all looks good, then I'll go pay for it. And then it takes about a week to get these back, and then when I get them back, make sure I didn't make some dumb mistake that caused a short circuit. And then what I did with these before is I populated the controller sockets first, or actually the USB, because those I'm most likely to make a mistake on. Did those first, and then the controllers, and then I did like a couple of the switches, and I made sure that it booted and didn't short out and the switches worked. And then I can go on to do the other switches and the LEDs. Look at that jagged red. Which jagged red? It's probably when I was zoomed in at some other point, right? I mean, there's one there. Is that the one you were looking at? Like that one? I think I'm trying to avoid that via there. That's why I have that. Oh, yeah, and this is trying to avoid that hole. You don't know which one's jagged. Okay, we'll probably run into it later. Oh, what's going on there? Whoops. Right there. That's too close. Let's move that. Let's move that out to Right around there. That's good, because it's like equidistant from the other things. Did that one have to be there? Hold on. Can I hide that pad? Well, that doesn't need to be there. It could be out here. Does it really matter? Could put it out here. I don't know. It doesn't matter, does it? Might as well just put it... Oh, I know why. I'm trying to avoid being under this part. That's why. And I almost undid that by mistake. That tells me that I'm getting tired, and I should probably end soon. So don't make any kind of silly mistakes. So the busiest parts of my board are like right in the middle lanes. Like right here is the busiest, right? Right where I tend to have the most vias, around the index finger. So that's where to expect the short circuits, I guess. And the edges, I mean, it makes sense. The edges are the least busy. The edges, I might have some unnecessary vias, right? Yeah, like I see one already. There's no reason for me to via around this guy, right? We could delete this whole net, delete that, and delete this via, and just go around like this. And that is just a redundant... Oh no, it's not redundant. We need that one. So the same thing here, right? I don't need vias out here. I didn't mean to delete all of that. We don't need these vias. We can just connect straight down to here. With a Y, right? Sure. Actually, and then I can avoid the topside copper entirely here. Just go around like this. Look at that. Okay, that's got to match. Come on. Come on, we got to make that match, right? Two 90-degree angles isn't so good. That'll make it better, right? A nice Y there. Yeah. Okay. Oh, another one I can do. Delete. 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 Little tiny bits that we can delete. Oh, what's that? Huh. Okay. And then just go up and over. That's got a nice look. I wonder if I did the same thing on the other side. Oh, indeed. I did the same thing on this side. Okay. Yeah, there's like no need to do this, right? Just keep it on the same layer. Little red guy there. Okay. X. There we go. Oh, okay. Because it's mirrored, these guys are connecting inwards instead of going outwards. Hey there, Dimi Tropopov. Can you put some limitations like distance to holes? Yeah, you can. I'm looking at it manually because I don't completely trust it, but there's this thing called the design rules checker, which I'm running, and it's got a downside in that it doesn't like my rotated parts. It claims that there's a problem there, and that this track is too close to this edge cut, but it's not too close. It's just that it's rotated. I think it's the bounding box is intersecting. But if it weren't for that, we could trust this completely, I think. Well, no, almost. I've seen a few places where tracks get close to edge cuts and it didn't come up in the design rules check. But the design rules check compares to your board setup, I think, where you can set some of these rules up. And some of the rules, like it takes into account as you're drawing even. So they're under these constraints here. So it's like minimum clearance, minimum track width, minimum annular width, minimum via diameter, copper to hole, copper to edge, through hole clearance, minimum via diameter. And these you can get from the manufacturer who's gonna make your board. I got them from JLC PCB, and I think I added a little bit just to be conservative. So that's where it all comes from. It's the constraints are set basically by how comfortable you are of the manufacturer you're going with, how capable they are. So if they have like really good machines that can get really good precision, then you can loosen the constraints. And if you're like kind of just anxious about it like I am, you can increase the constraints. But even though but like I said, I found cases where it didn't warn me about something getting too close to a cut, and I'm not sure why. So I like to look at it manually. Also, like if you have room, there's no, even though you're within the constraints, I don't see any reason not to just clean it up a little bit and like use the extra room. If we're not making a trace longer, if we're just like evening the distance that we have for a via to sit somewhere, I'm going to do it. I think it just sounds like a good thing to do. Kind of like refactoring code. Your code might work fine with no warnings or errors in the compiler, and it might run plenty fast, but you kind of want to clean it up to make it look nice. You always want to do something build like this, you don't know where to start. Okay, I have some suggestions for you then. If you want to make any kind of electronics and you don't know where to start, here's what you can do. You can go and look on YouTube KiCad. There are a couple channels actually I recommend. Well, DigiKey's got some, they got a good channel, but also, what was it? It's not showing who it's from. There are a couple, it's probably this one. Let me just click it and see. Yeah, DigiKey. So DigiKey has got like a really good intro series. And probably by watching these, you'll start to get other video suggestions. Yeah, Contextual Electronics is another good one. And John's Basement. So there you go. DigiKey, John's Basement, and Contextual Electronics. They all have like intro series on how to use the tool. KiCad. KiCad is open source, free, right? So you can download KiCad, install it, and then kind of work alongside these intro videos. And that's what I did. It doesn't take that much time to learn the basics. Yeah, now they have to find each other, exactly. So I picked a project, something I wanted to do, which is to build a keyboard, because when you get down to the schematic, there's a lot of copy paste, but there's really not a whole lot here. There's a controller board, there's a switch and a diode, there's a USB connector, and there's some LED lights. And a lot of them are just copy pasted because I have a lot of them. I made the smaller board first because I knew I'd make a lot of mistakes. Each one of these boards only has 6 switches, and I got a lot of confidence building that little board to now where I can upscale it to an actual keyboard I could use, which has 36 keys, and have more confidence that it'll work. So yeah, pick a project that sounds neat, plenty of YouTube videos, and just picking the right tools and the right teachers whether it's YouTube or something else, like gets you pretty much as far as you want to go. It'll get you past that initial hump of getting an introduction and being able to play around with the tools. And then like me, you just kind of try things out. You get used to how the tools work, and then it's all about refinement, like improving things in really small increments. Like you make a mistake and then you learn, oh, okay, next time I'll look out for that. Or like at first I didn't know how to route my traces around, and then someone in chat said, make one layer horizontal and the other layer vertical. And I tried that today and yesterday and got much better results. It looks a lot cleaner, right? There's not a whole lot of like weird squiggly lines. There's a couple places where it gets kind of busy, but the flow is obviously blue is left, right, red is up, down, right? So we have like conventions we're following. And then it's all a matter of when things have to connect or you don't want them to connect. You either have a connection or you don't. Not knowing where to start was the obstacle. Yeah. So definitely something like KiCad and looking for channels on YouTube that are reputable, like DigiKey, are good starting points, right? Getting kind of close to that hole unnecessarily, right? What if I... What if I just pull this trace back to that and then pull this one over? Yeah, why not, right? Okay, I think I'm done for now. I gotta sleep on this. It's past midnight for me. I might not stream any more of this, so because any more of this is just me nitpicking. I think I'm just gonna go and have this board printed out. And in the meantime, I'll just work on some of the software stuff. So, oh, I do need to double check all my silk screens. So, on the things left to do, let's pull that up. So, I did learn how to split this schematic up, but I'm not going to do that because I've pretty much squeezed everything in there and it's working. I did find a part for the underglow LEDs. I learned how to import the logo onto the silk screen. I'm not sure if I'm going to do these things because that would require me adding more chips to my board. Actually, I'm probably not going to do these, so let me just strike these out. I'm sorry to whoever suggested them. How do I add a strikeout? Can I even strike these out? I don't even know how to do that now. There we go, strikeout. I think the next thing I'm going to do is software stuff with mod and layer tap versus hold. And maybe do debouncing because I've occasionally seen bounces. So it's gonna be working on that next time, I think. One question before I stream it: how did you arrive at this design? Oh, easy. Hold on a second. Let me turn off my camera a second so I can go get something. Hold on, really quick. Sorry, I think I struck my microphone. Apologies for the noise. Okay, so how did I arrive at this design? I was inspired by this keyboard. It's called the Corn keyboard. I had this built for me. And doesn't it look remarkably similar to what I've designed here? Because I was heavily inspired by it. So I started with, you know, a normal 101 key keyboard, right? Standard thing. And then I tried mechanical keyboards. I got into that. And then I was introduced to a split keyboard design. And then a friend of mine had made a Corn keyboard like this, only slightly different. And he really liked it. So then I tried it out and I really liked it. And then I learned a little bit about how it's all open source now and you can do it all yourself. I'm like, cool, that sounds like a fun hobby. So I'm like, I want to make my own keyboard. I'm inspired by the Corn keyboard where it's a split design and then there are 36 keys What's really nice about this is that you don't have to move your wrists very much, and you can basically, with the help of layer switches, buttons on the thumbs, you can do all the keys on a full-size keyboard just by switching layers. So that was my inspiration, and I came to my design based off of those other designs. I don't know what I just did. I hit a key. Why not towards... Let me click on that and see what it is. That just looks like a variation on what I'm making myself. So what's different between what I'm making and... Oh, with columns fanning out. Oh, I can answer that. Why do I have these? Well, what I did is I put my hands on a piece of paper and then traced around my fingers to see what's my natural resting position of all my fingers. And that's what I sort of came out with. So literally, I position these keys based off of what's comfortable for my hands. So that's how I arrived at that. So it's different because this customized for my finger positions. Okay, what else do I need to answer? PCB editor is good for manual design. KiCad is if you want to write code for laying out. I haven't tried PCB editor. I write a KiCad because a friend of mine suggested it. This is short Korn. Yeah. So Korn has a breakable extra 6th column, and both my friend and I both decided to break off that 6th column because I don't want to have my pinky finger extend too far. Hold on just a second. Yeah, so the Korn keyboard actually does have a 6th column, but a lot of the times you can break it off. It's designed to be broken off. So it depends on your personal preference. I don't like to have my pinky finger extend off to the edge, so I didn't buy that variant. Did you draw the row positions on paper? Yes, I did. Well, when I drew... Okay, can I simplify this? Just show front layers only. And don't show the copper. So these are the home positions for my fingers that seem natural to me. And then one position up and down is just literally placing a key up and down because that's called like ortholinear, and I kind of like that on the Korn. And then I had to figure out where my index finger would naturally go to, like if I rotate it to the left, and so it was a little bit down, which is kind of like Korn. But yeah, I drew it out on paper and then I measured it, and I used that to pick the initial home positions and then extrapolated from that. Yours isn't removable? It's when you print the PCB, usually there's like, kind of like what I have here, these breakaway tabs will be strategically positioned between the 5th and 6th column, and so you just break it before you populate the board. But once you populate the board, of course, it's probably too late to break it off. Oh, cool. Yeah. Anyway, I think that's it for today. Next stream will be a couple days probably, and I'll be doing more software stuff on this proto board, because I gotta wait at least a week for this board to get manufactured before I can actually start soldering stuff to it. I'm also waiting on a few parts, so like these parts here. If I do I should have just flipped to 3D view, because this is what we anticipate getting back from the board house, right? Once it's fully populated. I ordered some of these NeoPixels and they're due to arrive on Friday, so I have to wait at least a couple days for those. I have the rest of the parts, but not for the entire board. I need to wait for more sockets, and actually that's it. Oh, and switches. I don't have enough switches. I only have these 12 plus 6 more, and these are not all the same. Half of them are whites and half of them are browns. Anyway, this will be cool. I'm not looking forward to soldering these pins, but I'm sure with lots of flux, it won't be that bad. So anyway, let's shut down. I don't remember if I checked this stuff in. I didn't. What did I do? Oh, I just did some cleanup. So we'll just call it PCB board cleanup. PCB like route cleanup. Push that. All right. Is anyone streaming? I wish I knew another streamer who was doing board design, because then that would be a perfect segue, right? But I don't. Well, Retro MMO is a friend of the stream, so I think we'll raid them. Wait, what am I waiting for? You know a streamer that's doing it? Really? A streamer that's doing PCB design? Oh, we have to raid them then, right? Oh, but this is not English. It's Korean. And I have to wait for an ad. He speaks Korean and English. Okay, good. And he's only got 7 followers. Oh, and he's only gone 15 minutes? Oh, perfect. Let's raid them. I gotta copy paste the name. All right. There we go. We set up the raid. Speaks Korean and English, doing board design. So, and he's got equipment set up and everything. This will be fun. All right, guys, enjoy the stream we're going to, that I can't pronounce because I don't know Korean, but its English equivalent is Juliday 97. So enjoy that stream, and I'll see you next time. Okay? Thanks for watching. Bye bye.